All right, in today's lesson, we are going to learn how to solve quadratics using factoring. So when we solve quadratics using factoring, we are trying to find the zeros or x-intercepts of the quadratics. So let's look at our first example. So our first step when solving any quadratics is first we have to make sure it's set equal to 0. In this case it is, so we're already set there. Next step, we are going to set up an MA table. What does the M stand for? What does the A stand for? Well, the M stands for multiplication. The A stands for addition. How we're going to find what we're going to add to is we're going to multiply the A and C value together. So in this case, A times C is 3 times -4, or -12. And we're going to add to -4. So next step, we're going to do choose factors that multiply to 12 and add to -4. So the question I want you guys to see is I want you guys to find factors that multiply to 12. So we got, for example, 4 and 3. One has to be negative, but no matter which one is negative, it's not going to add to -4 because -4 plus 3 is -1. -3 plus 4 is +1. So let's try different numbers. We got 6 and 2. Well, if I have -6 plus 2, of course, if we have added them together, we want the bigger one to be negative, so 6 should be negative. -6 plus 2 is -4, so that satisfies those conditions. So these are the two numbers that multiply to -12 and add to -4. So we're going to take this middle term of the quadratic. We're going to break it up using these two numbers that add to that -4. So we got 3x squared minus 6x plus 2x minus 4 equals 0. This 4 comes down just as is. And now that this -4x still exists, but it exists as the combination of these two terms. So that was our fourth step. Rewrite the linear coefficient using the sum that you found. Our next step is called factor by grouping. Factor by grouping is when you have a group of 4 terms like we have right here, and we're going to group them into sets of 2. So this first 2 and these second 2. And of that first 2, of those, the set of 2, you're going to look between the 2 terms in there and say, what is the greatest common factor? So between 3x squared and -6x. Personally, I like to start with the coefficients and saying, okay, between 3 and -6, what's my greatest common factor? Well, obviously 3 goes into both. And looking at the variables, both of them have at least one x in them. So the greatest common factor between these two is 3x. We're going to take this term and divide each one of it by this greatest common factor. So for example, 3x squared divided by 3x. Well, 3 divided by 3 is 1, and this x squared cancels out with this x squared. So we are just left with an x. In a similar way, -6x divided by 3x would be, these x's will cancel out, -6 over -3 is -2. In a similar way, we're going to look right here and say, okay, between 2x and -4, what is our greatest common factor? Well, obviously 2 is in both of them, because 2 divides 2 and 2 divides 4. And can we take out a variable from it? Well, no, the second one doesn't have a variable to give, so we're just going to take out the 2. So 2x divided by 2 is just x, -4 divided by 2 is -2, still set equal to 0. In a similar way that we were looking at these two terms earlier and say what's in both of them, we're looking at this whole thing and say what's in both terms. Well, obviously there's an x plus 2 in both, so we're going to take, in a similar way as we took the 2 and the 3x from the two terms above, we're going to pull the x minus 2 out from these two terms, from this first one and from the second one. That'll leave us with another term of 3x plus 2 equals 0. Now our last step is just solving. Now we have two things here being multiplied together. Let's call the first one A and the second one B, just to make it look a little simpler. If we have some two things, A and B multiplied together to get 0, what do you know about A or B? Well, we know that one of them has to be 0. So that means x minus 2 has to be 0, or 3x plus 2 has to be 0. So in this first one, what do we plug in for x to make 0? Well, we can do that by solving for x. We're going to add 2 to both sides since this is a negative 2. Please put the plus and the 2. That's just good notation. And over here, we'll do a similar thing. Because it's a positive 2, we're going to subtract 2. That cancels out. We get 3x equals negative 2. Now we have 3x equals negative 2. Well, between 3 times x is a multiplication, so we can do the inverse, which is division. Divide both by 3, and x is going to equal negative 2 over 3. So these are our two answers. Now I want to just show why they're two answers. If we plug these into the original equation up here, they are going to make this whole thing 0. I'm going to demonstrate that just so you understand what's happening. If we have 3 times, what was one of our answers? 3 times 2. 3 times 2 squared. Sorry, it's very important you put the square outside the parentheses. Minus 4 times 2. Minus 4, you will get the value of 0. But even more than that, when we look at a graph, if we plug this in, 3x squared minus 4x minus 4, and we look at the graph of this function, here it is. If we look at the value of 2, you find it's going to be in a very important place, and that's the x-intercepts. What we're looking at right here is not only are we finding the values that make 0, but we're also finding the x-intercepts of these two, of this graph, which is very important for later on classes. I'm going to do one more example. We have 0 equals x squared minus 5x minus 14. We do a similar process. First, we are going to check and make sure it equals to 0. Set equal to 0. It is. We are safe. Next step, we're going to set up the MA table. Multiply 1 times negative 14 is just negative 14. Negative 5 is our linear coefficient. So what number is multiplied to 14? Well, there aren't too many. We got 1 and 14, but of course that's not going to add in any way, shape, or form to 5. So let's try 7 times 2. 7 times 2 does give us positive 14, which means one of them has to be negative. And since our our addition sum is negative, we want to have the bigger one be negative. So let's check. Negative 7 plus 2 does equal negative 5. So good. Second step, we are going to rewrite the linear coefficient using this new sum. So using negative 7 and 2, so 0 equals x squared minus 7x plus 2x minus 14. Remember, we're not changing the value of this. We are just breaking up 5x into 2 terms instead of 1. Next part we're going to do is we're going to factor by grouping. Looking at this first group, between 1 and 7, there is no greatest common factor other than 1. So we're just going to pull out x. X minus 7, so we divide both by x. This next one, there's no variable in each, but let's check. Does 2 go into 14? Yes, it does. If 2 didn't go into 14, we had to look for other factors of that number. So we got x minus 7. That's still equal to 0. Since there's an x minus 7 in both these terms, we're going to pull that out to the front. Now that we have a set equal to 0, we can use the zero product property, which tells us that if we have two things, such as these two, being multiplied together, that one or both have to be 0. So we need to find numbers that could make x minus 7 0, or numbers that make x plus 2 0. Quick solve here. This is a negative 7, so we're going to add 7 to both sides. So we have 7 equals x. And since this is positive 2, we're going to subtract 2 from both sides. So if you have no money and you lose $2, you are below, you are negative 2. In a similar way, if I plug this in my calculator in the original, I could check that it will come to 0. And these are also the x-intercepts of the graph.